1, 1, 2, 3. Okay, so welcome to today's lesson, which will be based on our chapter of trigonometry. So it's chapter 22 in our book, page 497. And it's a fairly short chapter. There's not a huge amount in it. All right. A lot of it is based on the idea of right angle triangles. And the first thing that we have learned already, and that we're just going to refresh and go over again, is which we refer to as our theorem of Pythagoras. All right. So again, right angle triangle, 90 degrees within one of the three angles of a triangle, and based on the area. All right. So you're looking at, if we just scoot over here, we're talking about the area of each of our lengths or of the side of a triangle when we square them. So if we're looking at this a squared in here, so this red area here, that is based on the length of one side of the triangle A, which we would refer to as our hypotenuse. All right, the length of A to be squared, so again A by A, we're getting a square, is A squared. That red region there, that red square, the area of that is equal to the sum of the other two sides of the triangle when they're squared. So the length C and the length B. When we square those, so B here multiplied by B will give us B squared. C by C is C squared. Adding the two of those, these you will find will fit perfectly within the area of the side of the hypotenuse, which is A here. So Pythagoras' theorem, based on our right angle triangle, states that the hypotenuse, right, which in this case is A, to be squared, right, so that A there to be squared is equal to the sum of the other two sides to be squared. Okay, so whatever that is, if we square it, it will equal or should equal the length of the other two sides to be squared. All right. Let's take an example and we'll sketch and draw an example of that here. So imagine now here we've got a right angled triangle. More square there, a right angled triangle. There's my 90 degree sign to signify that this angle is 90. The side that is opposite the 90 degree side is always our hypotenuse. And for this example, we'll just call that x. So we don't know the length of that here. And if we look at the other two sides, we'll call, say, one is 6 centimeters and the other is 8 centimeters. So if I ask you to work out and find the length x in this right angle triangle, you would need to use the theorem of Pythagoras. All right. So our hypotenuse is the side that is always opposite our 90 degree sign. So it's always the hypotenuse to be squared is equal to the sum of the other two sides to be squared. And that's the way I prefer to learn it and to say it off, rather than A squared is equal to B squared plus C squared. All right. It is, I prefer saying it, the hypotenuse to be squared is equal to the sum of the other two sides to be squared. So what's that look like? Well, the length of the hypotenuse here in this example is x. So if we square the length x, that is equal to the sum of the other two sides to be squared when we add them together. So it is 6 squared plus our 8 squared. So on the left hand side we still have our x squared is equal to 36 plus our 64. Adding those two together, we're going to get, what is it? It's 100. All right. And to work out going from a square x squared to a single x, we have to get the square root of both sides. All right. Getting the square root of a squared number, we're simply left with x is equal to 10. So the length of this hypotenuse x is equal to 10. All right, and that's basically what our Pythagoras theorem states and how we actually use it. So for the first set of exercises there, I just want you to go, they're starting there on page 498. All right, so we're going to have a look at exercise 22.1. and we're going to have a look at questions 1 to 17, and we're just going to do the even numbers there. Okay, so that's your first exercise there. So pause your video, go off and do the even numbers there within 1 to 17 for yourselves. Okay, it's all based on Pythagoras' theorem and working out the lengths of sides using Pythagoras. Okay, assuming now you have paused the video and gone off and done that, the next thing we want to look at is bringing in trigonometry into it. So trigonometry, if we just show this layer here, all right, is based on our get out of this there now in a second. All right, no, there we go. So trigonometry, right, again, dealing with a right angle triangle. So again, here's our 90-degree symbol there. So again, we've got a right angle triangle. We're using ratios, okay, and the fact that we either know angles or know lengths in a right angle triangle here to work out either other lengths in the side of a triangle or other angles within the triangle here. Okay, so just looking at the diagram here, we have obviously our 90-degree symbol. So the side of the triangle that is opposite our 90-degree angle is always our hypotenuse. Okay, and it was up here for Pythagoras, it was always the hypotenuse to be squared. So this red here is our hypotenuse, the side of the triangle that is always opposite our 90-degree angle. We will then always be given angles. We might be given one angle identified here as A, or we might be given two angles, say A and B. But in this example, we're just given the singular angle A here, and if we look at the side, again, that is opposite angle A, well, it is this side here, right? So that is the side we refer to as the opposite side. So we have the hypotenuse, the opposite, and then the third angle will always be your adjacent angle, right? And for whatever triangle that you are dealing with, I would suggest the starting point is to label those three sides. Label your hypotenuse, generally just H for short. Figure out which angle you're dealing with, whether it be this one or this one. Label that as your opposite side, and then your third side is your adjacent. Now, how are we able to use ratios and the idea of labeling these sides here to work out various lengths or angles? Well, what we use, if we look in here, we can use our trig ratios here, so sine, cos, or tan, right? And that's how the longhand of them is up there. So sine, cos, and tan. So if I'm looking at this angle A here, sine of the angle A is equal to O over H. So what do I mean by O? What do I mean by H? O is opposite. H is hypotenuse. Cos of the angle A is equal to A all over H. Well, A is our adjacent, H is our hypotenuse. And tan of the angle A is equal to O all over A, opposite all over adjacent. This here, it is important to remember this off and learn this off, all right? But an easy way to allow us to remember that here is a little rhyme down here, all right? So we have a rhyme which in red here, the first letter represents each of your ratios here. So you have silly old Harry for sine. So silly old Harry. Caught a herring. Caught a herring. Trawling off America. Tan off America. So silly old Harry caught a herring trawling off America. So that is an easy way to remember these trig ratios there for yourself. Okay, and we'll have a look at an example now as to how we can actually work with some of these. Okay, and I would advise you as well to get your calculators out. Okay, so if we just take an example from the book, so go back into our books here. So here, this is starting on page 501, this section here. So if we just take, say, the likes of, we'll have a look at, say, question 1. So So find the sine, cos, and tan of the angle marked with a capital letter in each of the following triangles. So all this question is asking us to do. So find the sine, cos, and tan of the angle marked with a capital letter. So basically we're just trying to fill in the sine, cos, and tan and fill in OH and A in all of these various angles here. So I'm just going to do it for the first triangle here, and I'll leave you to do it for the second two. So for this first triangle here, right, well, sine of the angle A, okay, so we've got sine of the angle A is equal to, remember you're saying off your rhyme, silly, and what I actually should have said here, well, we'll label them in now in a second here, the various different side angles here. All right, so if this is our 90-degree angle, well, this is H, so this is our hypotenuse. This is the angle here, so this is obviously the opposite side, and then our third side is our adjacent. Okay, so that's one thing I actually forgot to do. Right, so again, back, silly old Harry. So sine of the angle A, silly old, which is 3, all over H, Harry, your hypotenuse, 5. Cos of the angle A is equal to, well, cot a herring. So cot a herring, so it is 4 all over 5. And then tan of the angle A is equal to trolling of America. So TO, which is your 3, all over A, which is 4. So that is your 3 ratios here, sine, cos, and tan, based on this first triangle here filled in. All right, so that's a very simple thing there to do. Now, as we go forward in questions like this, we'll see we have to do a little bit more than this. We would use this then to find what angle A is, given that we know the lengths of the sides here in the triangle. But that's for a section later on. Okay. If we take and scoot on, and we'll have a look at, say, 1 or 2 questions further on into this series of exercises here. So we'll say, I don't know, 6. Yeah, we'll have a look at question 6. It's straightforward enough. These again are just getting you used to working with your trig ratios, your sine, cos, and your tan. Okay, so here we are. This diagram here, the 3 sides here, this angle, so this symbol here, as you can see it me done out here larger, that is what we refer to as theta. So it is a Roman numeral, so theta. So that's what that symbol there is representing. So the angle theta of the 3 sides of the right angle triangle are shown in the given diagram. State whether each of the following ratios represent sine, cos, or tan of this angle theta. Okay, so remember, first of all, label up. Okay, so angle of 90 degrees, the side opposite the 90 degrees is always our hypotenuse. This is the angle that we're talking and dealing with, so this is the side opposite, and obviously then this is our adjacent. So we're asked to work out, well, sine, cos, and tan, so go out of red, go to orange. So sine of theta is equal to that, cos of theta, and tan of theta. Well, if we look at these, so the first one here is 4 all over 5. Well, 4 all over 5 is O all over A. So this is O all over A. And if I think back, which, say my rhyme, which of my trig ratios has O all over A? So is it silly old Harry caught a herring trawling off America? So O all over A is tan, right? So tan of the angle theta is 4 over 5. So the first one is our tan of the angle theta. 4 again is our opposite, so label it the opposite all over the hypotenuse, which is H, which of our three trig ratios? Silly old Harry caught a herring trawling off America. Well, it is sine silly old Harry. So sine of the angle theta is equal to 4 all of the square root of 41. And our last one then, labeling again, there is our A, which is our adjacent, all over H, which is our hypotenuse, and then that is caught a herring, cos. So cos of the angle is equal to your 5 all of the square root of 41. So all of these exercises here, if we look back to our copybook here, right, from 1 to 12, it's just getting you comfortable with working with your three trig ratios, labeling in, you know, which is which sine, cos, or tan, identifying and pulling off measurements and numbers from various different triangles to suit those three trig ratios. All harping back to our rhyme here, silly old Harry caught a herring trawling off America. So you'll be bored to death hearing me say that, but I want you to be saying that in your head the whole time, and to recognize that the rhyme represents the trig ratios here that we have to work with. As we said, as we go forward, we'll be getting into a little bit more complicated workings with these, but for now, we're just filling a lot of the time, filling in the blanks into each of the various ratios. Okay, so with that being said, I am going to ask you to go along now and do exercise 22.2, and we'll have a look at question 1 to 12 it is. All right, all. Alright, so pause the video there and head off and have a look at those. Okay, so the next thing that I want to look at here is just changing and talking about degrees. Okay, so when we're working with our calculators, all right, we want first of all to make sure that our calculator is in degrees. So I have an example here, an emulator of a calculator, but on your calculator, all of this on the top bar won't be displayed. You will either have degree, one of the D or G here, and we want to make sure the D is shown here for degrees. So to make sure that that D is shown, we're going to press the Shift key and the mode setup. All right, and you can see degree, radian, and I forget what that one actually is. So we want to be in degrees, so we're just going to press the 3 button there, and that gets us back, and you should have your D up the top there. All right, so that now is happy that our calculator is in degrees. Degrees can be measured in degrees, all right? So if you think of, say, the 3 angles of a triangle add up to 180 degrees, a circle at 360 degrees, we can also measure our degrees in what we refer to as DMS, so degrees, minutes, and seconds. So say if I just talked about, say, the angle, say, 25.5, all right? So if I press equals there, that's, and press my SD button, is 25.5, okay? Because we're in degrees, it's referring it to as degrees. If I look at this button here, right, and I click this button, that changes my 25.5 degrees to degrees, minutes, and seconds. So it will change the 25.5 to 25 degrees, 30 minutes, and 0 seconds. If I press it again, it reverts it back to degrees. Press it again, degrees, minutes, and seconds. So if I put in another angle, so 12.27 degrees, we'll say. All right. Press my degrees, minutes, seconds. It changes the degree to degrees, minutes, and seconds. All right. So that's one thing there that your calculator, and sometimes we're asked to do, is just change from one form of measuring an angle to another. This is basically based on where our number system originated from numbers of the base 60. So it's all to do with 60s. That's why they say there's 360 degrees in a circle. 60 goes in evenly. 60 minutes in a 60 minutes in an hour, 60 seconds in a minute, and so on. All right. So degrees, minutes, and seconds. And we're just using this button here to convert from one to the other. All right. So that's one thing there. Now what I'm going to have a look at and talk about here is using our trig ratios to work out sides in a triangle. So if I was to draw out a triangle here, again, a right angle triangle, as accurately as I can here for us. So there's our right angle triangle, 90-degree symbol in here, and I'm going to include then into that then the hypotenuse is 12 centimeters. All right, and I'm going to label this side X and this side Y. All right, and I'm going to put in here then this angle here, and we're going to give that angle that it is 35 degrees. All right, and I'm going to then ask you to work out the length X, work out the length Y of this triangle. Now, if you knew X or Y, and so basically if you know 2 out of the 3 sides, well, you could have used Pythagoras to work out the third remaining side. But we're not given 3 or 2 sides. We're only given one length, the hypotenuse, and an angle within it. So I can use the fact that I know that this is a right angle triangle. I can use my trig ratios here to work out either X or Y. Okay, so we'll go on ahead first of all and we'll look at working out the side Y here. So if this here is my 90-degree symbol, well, the side opposite is always my hypotenuse, so we'll change color here. So this is always hypotenuse, so that's my H. This is the angle in question, so this side is always the opposite to it, right? So that's O, not E. And then this obviously is our adjacent. So now we're free to use any one of the 3 trig ratios here, which include O, which is our opposite side. Okay, so and the first one to do is, say, silly old Harry. So sine of the angle A, so silly is equal to O all over H. Okay, so silly old Harry. Now let's fill them in. So sine of the angle, and the angle is 35 degrees. So sine of 35 degrees is equal to O, which is our length y all over h, which is our hypotenuse, which is 12. Okay, what I'm going to do now is, obviously we want y is equal to, so I'm now going to cross multiply, or not cross multiply, but I'm going to multiply both sides, should I say, by 12. All right, because if I'm dividing here by 12 and I multiply by 12, we're going to cancel that division of 12 out. And I'll just do it longhand here just to show you for the first go. Right, multiplying and dividing by 12. 12 goes into 12 once and once, so you're getting y all over 1, which is just y. So on the left hand side here, you have 12 times sine of 35 degrees is equal to y. So we now want to work out that value of y there. Okay, so if I just move this a little bit over here, all right, on your calculator here we have 3 buttons for the 3 trig ratios, so sine, cos, and tan. So I'm simply going to put in this sum here. So I'm going to have 12 multiplied by, or in brackets, sine, because we're dealing with sine, of the angle 35 degrees. Close that. Now that bracket here is only closing this bracket. We have also got to close this one. So bracket again a second time equals, and we're going to get 6.88, and I'm just going to leave it to the 2 decimal places here. So y then is equal to, within here, 6.88 centimeters is equal to y. All right, so I'm using a trig ratio where one of the values here is the one I'm trying to find. The other value is a value that I know. There would be no sense in using, say, tan here, because I don't know x and I don't know y, so I'd have 2 unknowns here and I wouldn't be able to solve it. I need to make sure the trig ratio here, one of the sides is the one I'm trying to find, and the other one is the one that I actually already know. So now let's go on ahead and we'll find x. So we'll change to green for this. All right. So x here is our adjacent side. So in whichever ratio that you pick, it has to include the adjacent. So the next one there after sine is cos. So we'll talk about, say, cot. So cos of A is equal to cot A herring. All right, cot A herring. So cos all over, which would be x, all over h, which is 12. And the angle A is 35 degrees. So cos of 35 degrees is equal to A, which we don't know, which we're trying to find is x, all over h, which is our hypotenuse, which is 12. Multiply both sides by 12. Is equal to x. So I'm skipping now from here down to here. You can see what I've done here. And take out our calculator again. I'll move this to this side this time. So again, cancel that. So 12 multiplied by cos this time of the angle 35 degrees, and that is equal to 9.82, which will be 9.83 if I round it up. So 9.83 is equal to my side x. So there you can see we can use trigonometry, our 3 different ratios, sine, cos, or tan, even though we didn't use tan this time, to work out unknown lengths in a triangle, in the side of a triangle. Okay, that is one part there that we can use. We could also use it to work out unknown angles if we were asked. All right, and I'll do an example of one of those later from the book. The other thing there is what we want to refer to as an inverse function. All right, so say this time here now, so I'll take an example from the book. Okay, so let me see now if we just get the right one here. All right, yeah. So if we just take the idea of this one here, so we'll just screen grab this. Oh, is that the one? No, that's not inverse. One second, I'll pause this and I'll come back in and get the right one. Okay, so we're going to screen grab down here. Okay. So up here we've looked at using our trigonometry ratios to find unknown lengths in a triangle when we're only given one length and an angle. If we look over here, we're given two sides here within a right angle triangle, and we've an angle B here marked. And a question might be posed to us: work out the size of the angle B, or the measure of angle B in here, just with the information that we're given. Okay, so what I'm going to do here is, first of all, label our sides here. So this is our 90-degree angle. So this side opposite here is always going to be the hypotenuse, H. If this is the angle in question, well, this is always your opposite side. And then this is, even though we don't know it, that's your adjacent. All right, so to work out, and you can see the result here is 34.8 degrees. So we'll see how did they arrive at that conclusion there. Well, what of my three, or which should I say, of our three trig ratios includes O and H? All right, well, if we think silly old Harry, caught a herring, trolling off America, silly old Harry. So sine of the angle A is equal to O all over H. So silly old Harry. We know O and we know H. Sine of the angle B. So I'm just going to change A to B here. So sine of the angle B is equal to O, which is 4, all over 7. How can I use this now, this part here? How can I use that to work out what B is equal to? Well, it's using what we call an inverse function. So an inverse function is a function that we apply that will get us back to the start where we were. So having a look, if I'll write it out here and I'll show you how to do it on the calculator then. But if we get the inverse, all right, so we're going to go sine inverse, so basically minus 1, that's the way we write it, of the fraction of 4 all over 7, that will equal our angle B. So the inverse function, whichever function we're using, sine, cos or tan, the inverse of that function of whatever it is equal to, be it a fraction or a decimal number here, we get the inverse of it, and that will work out to be angle B. So if we open up our calculators here, how do we get the inverse function? Well, these are the standard functions, sine, cos or tan. If I press my shift key before I press whichever function I'm dealing with, now look at here, sine to the minus 1, exactly as I have it here. And now I'm going to go by 4 all over, I have to delete that, 4 all over 7. And that then will equal 34. So I'm writing that in 34.8, we'll call it 85, correct to 2 decimal places. So 34.85, correct to 2 decimal places, is equal to the angle B. And look at what they have got. They have only wrote to 1 decimal place, but 34.8, we've got 34.85. So you can see there, that's where they got this 34.85 or 8 degrees here. So having a look at this again, what did we do? We were given a triangle, and importantly a right angle triangle. We were asked to work out the measure of angle B. We needed to consider which of our three sine, cos or tan ratios included the two sides that we knew the lengths of. Now it was important that we knew both of the lengths of those, or else we couldn't have worked it out. We figured out that sine included silly old Harry, included our O and our hypotenuse here, the opposite in our hypotenuse, and we simply fill those in to get what's in this box here. From here, how do we work out what angle B was? Well, you simply work and you use your inverse function. So you get the inverse of whatever sine of B is equal to. In this case, it was 4 all over 7. So we get the inverse of 4 all over 7, and we let that equal to B. Typing this into your calculator, we figured out that that was 34.85 degrees. Okay, so that is now allowing us trigonometry to work out sides in a triangle or angles within a triangle. Okay, and that is basically the height of your trigonometry. Okay, it is first and foremost Pythagoras. If we know two sides here, we could work out the side of A here with Pythagoras, and we'll just do that as a refresher for you. So hypotenuse to be squared, which is 7 to be squared, is equal to the sum of the other two sides to be squared. And obviously we don't know what x is down here. We'll call this x down here. Working this out, 7 sevens, 49 is equal to 16 plus x squared. I want x squared to be on its own, so I'm going to have 49 minus our 16 on this side is equal to our x squared. And so what is that? 49 minus our 16 is our 33. So 33 is equal to x squared. I'm going to just jump over here now with it. So get the square root of both sides. So the square root of 33 will be equal to x, and the square root of 33, you could leave it as that, or if you actually want to find the decimal place of it, it'll be 5.7. Alright, is equal to x. So first and foremost, trigonometry harps back to Pythagoras' theorem, where we can use Pythagoras to work out the length, the third side of a triangle if we know two of them. Or if we don't know, if we're only given one side and say an angle in between, we can use our trig ratios to work out either your x or your y lengths. Or you might be given angle or lengths in a triangle and asked to work out the angle within your triangle. Okay, so having a look at the book as to how questions are laid out like that. So basically, say we're given the idea of this triangle here. This theta is our angle marked here. We've got the hypotenuse 14, and we've got the adjacent side of 7. How do I know it's the adjacent? Well, this is my angle in question. So this side is my opposite. Hypotenuse, opposite, last one has to be my adjacent. And you're using your trig ratios there to work out the angle theta in that case. Okay. And there's some examples there also. So some of these, like these are more kind of some of the practical questions here. So if we were looking at, we've got a person standing at point A, they're looking up to the top of the lighthouse there. The height of the lighthouse is 30 meters, they're 20 meters away from it. What is the angle of elevation? How high are they looking up? All right, or there's two boats here, you know, what is this distance from Q to R, maybe it might be asked, or whatever. You know, there's loads of questions there. Okay, so what I want you to do here now is there's going to be a number of days homework in this. Okay, so the first section here, we'll just do it again in yellow to keep a bit of unity. So the first set of exercises here is our exercise 22.3. I want you to have a look at questions 1 to 13. So that's the first one. Okay. Following on from that, your next day's homework will be exercise 22.4. And we'll have a look here then at question 1 to 13 also. Now there's more than 13 there, but I just want you to go as far as 13. And as I said, don't be given out to me. Sorry, that's, oh yeah, 22. Yeah, 22.5 is the next one. That's the last of them. Questions 1 to 18. All right. These especially are harder questions. They're more visual. They're the likes of the ones that we just looked off at here. So they will take a little bit of thinking and a bit of figuring out to do. But if you're happy and confident in those, especially these latter ones, the likes of 15 there and 16 or 17 and 18, then you'll be doing very well for yourself. Okay. So as I said, there's a number of days in this. All right. So it's not all that I want you to do all of those questions just in one night. Break it down, and I'll have you figured. I'll have you guided as to when and how to space that out for class. Okay, but that's basically trigonometry in a nutshell, based on a right angle triangle, theorem of Pythagoras, and also your 3 different trig ratios, remembering your sine, cos, and tan. All right, and your rhyme of silly old Harry, caught a herring, trawling off America. Okay, best of luck with those. Take care, and we'll talk to you again.